setup, how to get the robot ready with our tools. Next slide.
Pit setup. So when setting up the pit, we prioritize being organized and making sure all of our tools and equipment are readily available. For example, if you need something, you want to be able to get it now, especially during the tight turnarounds that you sometimes face in elims. We also strive to stay organized and make sure everything is put away where it belongs. Inside the pit, we like to have trash can, benches, pins, a computer, essential tools, and spare parts. And this is an example of one of our pit setups from a previous competition. Next slide.
Yeah,
Are you okay with questions like in between, or should I wait till the end?
Waiting till the end is preferred.
Okay. Then our robot cart. Every team has a different one. Ours has a bunch of features that we found useful over time. You can see a photo of it here. We have water bottle holders for our drive team, a flag holder. It has shopping cart drive, which means the back wheels are fixed, whereas the front wheels are swerved, because that's what we found helps us best move around in pit and steer through the crowds of people. The wheels lock, so when we're trying to fix something, the robot isn't moving. It has the driver station attached, tool organizer, bottom access to the robot, which is especially useful for us because we have bottom-mounted electronics and our batteries go in from the bottom. And the wheels spin freely, which allow us to do systems check without having to pick up and move the robot. For our tool specifically, we keep each tool on a labeled particular spot on the robot. You can see the containers at the bottom there. That way, if for some reason we don't have time to go back to pit, we have a short turnaround, we're going to the practice field or queue, we have all the tools we need to make quick repairs there with us. Next slide.
Spares. What do we actually need spares for? All of our 3D printed parts we have spares for. 3D printed parts tend to be the weakest link, especially if that's a pulley or a gear or something. Plates and shafts over frame perimeter, because again, other robots are gonna eventually bump your robot at some point, whether that also game pieces can damage your parts. So you want to be able to easily replace those. Motors and everything that is previously broken before should have spares. Whole mechanisms of smaller swaps are inaccessible, so in this year's robot, we can take out the whole end effector and slide in a whole new one if need be. And for storage, we're still testing different systems to store the spares most effectively, so trying to prioritize how fast we can actually get access to those spares while minimizing the amount of space it takes. And currently, we use one big tote with each mechanism inside its own labeled bag. Next slide. For each match, getting the robot ready. Next slide.
So as soon as our match finishes, we got the robot back, or it's even on its way back, we're going to start checking the batteries for the highest voltage one. And it's even better to do this before the robot gets back, because that way we're able to focus on the robot when it's there. Also, whoever is in charge of pit is going to announce if we're going to do a bumper change, how many matches we have before our next one, and who should do what additional tasks. For example, you could say, okay, we have a 10-match turnaround, we're going to need to change bumpers, and it looked like the intake got a pretty bad hit, so someone should make sure to double check that. If we know an issue, like we saw something break, then grab the specific tools we're going to need to replace that. And then we all head to the pre-communicated meeting spot that we talked about with Drive Team about. Are we going to practice fields, are we going to queue, or are we coming back to pit? Next slide.
Being ready on time. So to ensure we're going to be ready for each match, we use Nexus. The link is frc.nexus. There's also a QR code in the most packets you get at the start of each competition. We really like Nexus because it displays helpful information for managing your time as pit crew. For example, it shows the estimated time to queue, bumper colors for each match, and your record. All of those things are super helpful just to make sure you can get to the next match on time. Next slide.
So for our batteries, we really want to make sure that our batteries are the best they can be, so that way our robot isn't limited. We use the CTRE battery beak, you can see a photo here, to check the voltage of our batteries. We want ones that are at full capacity, which is 130%, and have a voltage of at least 13.4 volts. We always bring at least 10 batteries to each event to ensure we always have one or two that are fully charged while the others are recharging. We also got a new battery tester, which tests how fast the voltage on the battery drops, which we use to figure out which are the best 10 batteries to even bring to the competition in the first place. We also mentioned this before, but we leave batteries on the charger for as long as possible to make sure they're as charged as they possibly can be. And we also leave a second battery on the robot cart in case something goes wrong with the first battery. The drive team and technician can quickly just do a swap on the field. Next slide.
So what do we actually have on our pit crew checklist? So how the checklist actually works is between each match, all of pit crew works together to fill out the checklist. This ensures that we haven't missed anything and we are able to check the key different subsystems and common breaks just to make sure that doesn't happen again. So on our checklist, we have a spot for the match number up on the top. So that can be referenced later. So for example, if something broke, we want to be able to identify if that was actually checked or not and how we can improve our checklist process for the future to prevent that fix, well, to prevent the break from happening again. It's also grouped by subsystem, so people can go subsystem by subsystem, or different members on pit can each focus on one subsystem on their own. It's also labeled high, medium, and low priority tasks. So if we have a lot of time, we're going to be able to do those low priority tasks, but if we have a quick turnaround, we're going to prioritize the high and medium priority tasks. We also consult each subsystem lead before competition about potential issues that might arise, so the checklist is as comprehensive as possible. And we also update it as things break. So for example, this item right here, the numpad, that wasn't an issue we were having at our first competition, but eventually we started noticing that as the connections in the numpad broke, because it was a pretty cheap numpad, we wanted to make sure that it was actually connected to the computer before each match. So we decided to add that task to the checklist. Next slide.
So the way that we actually implement the checklist is we do one checklist per match the whole team shares. It's attached to a clipboard, which we then pass around. So I'll finish check the intake, I'll take the clipboard, and then I'll pass it to whoever needs it. If once you verify an item, you're sure that it's good, then you write your initials with it. That way we're able to, if something does break, we can go back and see what was the mistake here, how can we make sure it doesn't happen again. We also try and rotate which subsystems people do. So I do intake this time, I'm going to do end effector next match, and then maybe I'll do climber after that. Because everyone notices different things, and so having that rotation makes it more likely that we're going to catch an issue that maybe I would never catch if I just check that one system over and over again. Also, if there's time, we have 2 people check every subsystem. That way we can, again, catch anything in case it was missed by the first person. Next slide.
So before each match, we do a systems check. During the systems check, we operate all key mechanisms. For example, the intake, elevator, swerve, and climber. We ensure they work as intended, and including, to build on that, we also check the camera streams to make sure that our auto and our localization works properly. Here's a list of some things that we check in our systems check just to make sure that they work correctly. Next slide.
Then, of course, the biggest thing, what do you do when something does inevitably break? So first you want to look at what will happen if we don't fix this. Is this a critical issue? Do we need to fix it, or can we just let it go? And also, how long will it take to fix? Can we do it in 10 minutes? Can we do it before our next match? Can we wait till the end of the day and then we'll have time to do it? Then, once you've decided that we need to fix this and we have the time to fix this, you want 1 or 2 people working on the issue. Because we have 4 people in pit, it's those 2 people's priority, and the others will continue with the checklist or doing anything else that needs to be done for the robot. Once this is fixed, we want to make sure to notify drive team and strategy if there's important changes to robot functionality. For example, in the past, we went to the practice field and we changed the sight angle of our barge shot. So we had to notify strategy that, hey, we think there's going to be an increase in accuracy for this barge shot, and told the driver that it's going to be more reliable. Then, if applicable, run a systems check. We talked about this. So if you change something on the intake, then check the intake again. Just have it intake some coral, see does everything still work as it intends. And finally, when you have time, log the issue. We like to have a sheet where we keep track of everything. Sometimes it's a thread in Slack. And that way, after the competition, we can go back and look and see, okay, what broke? Do we need more spares of this? Do we need to redesign this? Whatever it is, to make sure it doesn't happen again. Next slide.
So here's some example issues that we faced in the past. During, I feel like it was SFR, these terminals, one of the actual crimps, it was sheared almost completely in half. So this meant that that connection was super risky, and we identified the issue, but as we were in queue at that time, we decided that we had to play that match and solve it in the future. This is an example of an issue that we've identified, but we've had to decide that we couldn't actually solve it at that second because the match was super soon. Another issue we faced was the indexer. At Chesney, our indexer was moving quite slowly, so during that match, we were able to diagnose the issue by looking around and seeing that the terminals on the Kraken, they weren't actually tightened down enough, and then we were able to fix it then before that match, and before the match.
To
And then-
elaborate a bit more on that, what we did is we weren't sure what the issue was for a bit, so we had to run a systems check. We intook piece after piece with people photographing the thing so we could see exactly in which part of this handoff sequence is the failure. And that's how we were able to find that Kraken terminal was loose and address the issue.
Thank you for that. And then on our final issue, it's a little bit hard to see, but right here you can see our climber plate. Over time, especially in our first regionals, that plate was getting increasingly bent. And we actually were able to we evaluated the problem and realized that it wasn't a big deal. We could live with it because it wasn't actually impacting our climb that much. So we have continued with it over the season, and it's the same today as it was in our first regional. Next slide.
So thank you, that's the end of our presentation. Our hosts have asked us if you could fill out this form, which is just a feedback form, I'm not really sure what it is. And then we'll open to any questions, comments you have. You had a question earlier? Yeah?
I was wondering how so you have 4 specific members who are designated to be like pit. How do you factor in like the technician into that? How does that communication go, or are those people ever the same?
So for us, our technician is on partner prep. So they're the group who is making sure that our partners are ready for the next match. So usually we address the issues in pit crew, and if it's something they need to be notified of, we'll tell them. Sometimes there's an issue that we think they'd be able to help on, such as it's a mechanism they designed, so they're going to be the expert, and then we'll call them in and they'll come in and help out.
Okay. So for the most part, they're just
Yeah.
Who's like the primary person or people that train you for the different problems that occur?
So, in general, the 2 people that train you for pit crew itself are those 2 experienced members that are permanent pit crew during the competition. So they'll be there at every single during every single match, and the rotating members, they'll watch and see how those fixtures actually occur. But if it's a subsystem that you designed before the competition, you'll actually walk through that subsystem with the pit crew, help them identify what problems or potential issues that might arise, so that can then be put on the checklist. And for example, if it's super complicated mechanism, like our pivoting system this year, like the carriage was pretty complicated, they actually helped us understand how we could fix that and refer to the CAD. So if an issue did arise, we could fix that. Does that clarify things?
Yeah. Thank you.
Does anyone else have any questions? Okay. Thank you. Appreciate it.